Steel, the strength, the backbone of our modern world. Just as steel touches our lives in thousands of ways, steel is not one product, but thousands of products, covering many grades of carbon, alloy, stainless, or specialty steels to meet very specific application needs. Steel making is a massive enterprise that might seem confusing. But it's really not once you understand the basics. For simplicity, let's look at the steel making process as having 5 general steps. 1. Raw materials are gathered and transported to the blast furnace. 2. The blast furnace turns the raw materials into molten iron. 3. The molten iron goes to another type of furnace where it is refined into steel. 4. The molten steel is formed into primary shapes, slabs, blooms, or billets. And in the 5th and last step, these primary forms are shaped into finished products, such as sheet, pipe, bar, or wire. Yes, there are offshoots here and there in the process, but let's stick to the 5 basic steps: raw materials, iron, steel, primary forms, finished products. Let's take a closer look. Steel making starts with raw materials. The principal ones are iron ore, limestone, and coal. One of LTV Steel's main sources of iron ore is taconite, an extremely hard rock. The iron ore is locked up in this rock. So a lot of refining must be done to get high-grade iron ore pellets, well suited to blast furnace operations. We bring the iron ore pellets down from the Lake Superior region in the most modern carry their own conveyor and dockside unloading equipment. The other principal raw material is coal, which has to be converted to coke in these ovens. It is the basic fuel. Coke is highly concentrated carbon, and the carbon is an essential ingredient in the chemistry of making steel. It's the carbon that will ultimately make the difference. LTV Steel is in an excellent position regarding raw materials availability and processing. We have the newest, most efficient materials transportation and handling system in the world at Lorain, Ohio. And we have modern computer-controlled coking ovens and specially designed hoods and coke cars which prevent smoke and dust from escaping into the air. So we take our basic raw materials, iron ore, limestone, and coke, a derivative of coal, to the blast furnace, where we make molten iron. We blast these raw materials and some additives with high-pressure hot air to produce molten iron, the fundamental metal in steel making. Every 4 hours, the blast furnace is tapped, and a cast of molten iron weighing 500 tons is drawn off. Samples are taken to analyze the ratio of elements in the cast. The iron is kept in a molten state in specially designed rail cars. Now to the steel-making furnaces. LTV Steel uses the most modern methods in the world to make steel, not the older traditional methods like open hearth furnaces. The most common types of steel-making furnaces today are basic oxygen furnaces, BOF, a refinement of the BOF, the cube-op furnace, and modern large-capacity electric furnaces. LTV Steel utilizes BOF and electric furnaces depending on end product requirements, but we'll also discuss the QBOP. Let's look at BOF and QBOP steelmaking first. The BOF furnace, it's tilted and charged with scrap steel. Then we add our molten iron from the blast furnace. A lance lowers to force oxygen into the furnace at high flow and pressure rates. A hood around the top of the furnace captures 99.9% of potential air pollutants. LTV Steel's closely monitored BOF pollution control system has huge ducts that cover. This 20-story high system prevents 200 tons of particulates from escaping into the environment each day. At the proper temperature, lime and other important additives are introduced into the furnace. In only about a half hour, the oxygen blow rapidly reduces impurities and produces steel of specific grade and characteristics for a particular end use. In the QBOP furnace, a refinement of the BOF system, oxygen and other gases are blown in from the bottom, not the top of the furnace. LTV Steel has applied solid-state technology to BOF operations to calculate chemistry, composition of charge, and to monitor the rapid cycle of refining that takes place in the furnaces. An experienced operator oversees the entire process. Samples of the steel are taken from the furnace for rapid analysis in the laboratory to be sure we got the chemical composition within specified levels. Another modern and efficient steelmaking method is the electric arc furnace. Electric furnaces are top charged with high-grade alloy scrap and are used mostly to produce high-quality alloy, stainless, and specialty steels. Large electrodes are lowered into the furnace. An arc between the electrodes and a metallic charge creates intense heat. Smoke created by the arc is drawn off into a massive pollution control system. Sophisticated techniques are used to further process the electric air melt steels for very specialized high-technology applications. These advanced methods are argon oxygen decarburization, AOD, vacuum arc remelting, VAR, and its companion process, electroslag processing, ESR. A brief look at these processes. The argon oxygen method replaces oxygen with argon. There is a high degree of computerized control in the AOD process. In response to the input of the grade of steel wanted, the program states the exact chemistry needed. The vessel is electronically controlled through the entire 2.5-hour blow. VAR and ESR are advanced methods used to make super clean steels for bearings, aviation, and aerospace components. These two production methods double refine steel. They minimize the gases and other minor inclusions trapped in the steel, resulting in a virtually flawless product. The melt rate is monitored by a computer system for optimal quality and productivity. All right, we've got our molten steel from the BOF, QBOP, or electric furnaces. Next, it is necessary to shape that steel into primary forms that are manageable. Shapes such as slabs, blooms, or billets. From these forms, finished products will be made. These primary forms are made in one of two ways. The first method we'll look at is ingot rolling, a multiple-step operation involving ingot teaming and ingot breakdown mills. The second method, continuous casting, is a one-step process from molten steel to finished slabs or billets. In the ingot mold process, the molten steel is poured into molds, allowed to cool, and the mold is stripped off. The solid ingot is reheated and sent to the blooming mill, where it will be shaped into slabs for suitable forms for billet mills. The second method, continuous casting, is one of the newest forming methods. LTV Steel has two of the most modern and efficient continuous slab casters in the world located at our Indiana Harbor and Cleveland Works, and a billet caster located at the Canton Works. The continuous casting process begins with molten steel from the steel-making furnaces, which is transported in huge ladles to the continuous casting shop. After the molten steel has been precisely treated for temperature and chemistry, the ladle is placed on the ladle turret and rotated 180 degrees to its casting position over the tundish and the mold. The tundish and the ladle are then lowered into casting position and the cast begins. As the high-quality molten steel leaves the ladle, it passes through a ceramic shroud to the tundish and through another shroud into the casting mold. As molten steel begins to solidify, it travels through the continuous casting machine where it is gradually straightened and cut to specific slab lengths. The Canton Works billet caster produces billets in a vertical strand, which are cut to specified lengths and lowered into position for further processing. Continuous casting is a more energy-efficient process than ingot rolling because the molten metal is converted directly into slabs or billets. The primary steel forms are now ready for finishing operations. Slabs of steel go to rolling mills to make flat products. They go to hot strip, scalp, or plate mills for their finishing operations. Hot strip further processed by cold rolling into finished coiled and flat rolled products. Scalp is finished as welded pipe, and the plate mill produces a steel plate for finishing to exact size and gauge. Billets are finished into various shapes. They are hot rolled into bars, flats, rods, or tube rounds. The hot rolled bars can be further processed by cold drawing or squeezing into rounds and angles. From the rods come wire products. Tube rounds are used to produce seamless pipe. Now let's watch how slabs are finished into various flat-rolled products at one of LTV Steel's hot strip mill facilities, the most modern and sophisticated mills in North America. The mill quickly reduces the thickness of the slab and produces a long ribbon of steel. Computer-generated models and sensors on the mill determine and control proper temperature, roller spacing, and speed. Through each stand of the mill, there is close monitoring of critical factors affecting final product quality. Thickness, for example, is precisely gauged by low-level gamma rays, while the steel strip moves at speeds of about 50 feet per second. The long ribbon of steel is rolled into coils. Most of this steel will be put through a pickling process and then cold rolled to final shape. The final product is eventually used in a variety of automobile, appliance, and other sheet metal parts, as well as scalp for electric resistance welded pipe and pipe products such as hydraulic lines and boiler tubing. Hot rolled bars are one of the most important product groups of the steel industry. Bar stock can be made in a wide range of diameters from 1/4-inch round to 11-inch round and up to 26-inch square at LTV Steel. Internal soundness is very important on bar stock, so various methods are used to inspect the products for seams or fissures too small to see with a human eye. Non-destructive testing methods such as eddy current or magnetic particle testing are performed. Grinding is used to remove surface imperfections and in some cases to finish to specification. After passing inspection, the hot-rolled product is finished for shipment to the customer or is further refined by cold drawing, where the bar is drawn, polished, and ground for extreme accuracy and precise finish. Seamless tubing starts out as a solid round, a tube round. The solid is heated to a plastic state. It's pierced and hot worked progressively larger and then sized to final diameter. This tube will be used for oil well casings, gas lines, or other energy-related applications. At LTV Steel, we literally move mountains, create and harness volcanoes to make quality steel products. As we've seen, the process of making these steel products is relatively simple. Raw materials, to the blast furnace to make iron, to the steel furnace, BOF, QBOP, or electric, to primary forms that are finished into flat, round, or structural shape products, and finally, to myriad products that shape our modern way of life and the future of mankind.